So link local addresses will be allocated by devices to themselves dynamically. They will create it automatically because it will always start from FE80 and rest, I mean last 64 bits will be copied from its MAC address. However, your MAC address is just 48 bits long address, but it will add EUI, equipment unique identifier, that is again 16 bits long, and that is fixed triple FE, and this triple FE will be inserted in the just middle of the MAC address, right? So 48 bits were already there in MAC address, and these 16 bits from EUI will be added into that MAC address, so that finally 64 bits will be completed, right? So interface ID in link local address would be created with the help of MAC address and EUI, right? And one more thing, that 7th bit will always get changed, right? Like if it is 0, then it will be 1, and if it is 1, then it will make it 0, right? Inside the interface ID itself, 7th bit will always be changed. So I will prove it over here, right? So let's have the console of R1 first of all. So to enable IPv6, actually you see, say IPv6 unicast routing, right? So now we have enabled this IPv6 unicast routing on R1, and then you do one thing, go to F0 to enable IPv6. It's very simple, IPv6 enable. Once you will configure this command under this interface, you will see that it will create a link local address automatically, right? So you see that once I said it, okay, one more thing that you need to do, F0 so no shut down, right? Now say show IPv6 interface brief, check it out. This is the link local address, right? This is link local address, right? And it is starting from FE80 dual colon, and these last 64 bits will be known as interface ID, and these last 64 bits will be calculated or will be generated with the help of the MAC address of this interface, right? When you can look at this show interface fast signet 0 by 0, you see that this is C200 and like this, right? So this time I'm gonna to convert it into interface ID. So what will happen that triple FE will be inserted in the middle of the MAC address, right? Triple FE, and then later on 7th bit will also get changed. So in place of 2, it will make it 0, because this 2, which means 7th bit will be 1, and you will make it now 0. So it will become C0000. Let me do one thing. This is what? C200. Tell me C200. Then it was 0D7C, 0D7C, and then 4 times 0, right? Now if you want to create interface ID for IPv6 address with the help of this MAC address, it is quite simple. It will take triple FE, will insert it in the just middle of the MAC address, right? So it will become C200 colon 0D FF, right, colon FE7C colon 000, right? And then further it will convert it into the binary. So C, which means I think 12, right? So 1100, right? 2, which means 0010, right? And then 0, which means it will become 000, and then again 0000. You just need to convert 7th bit. So 4 3 7, this is 7th bit, right? 1 is 7th. If you change it now 0, right? So it will become now C000 0D FF FE, I mean colon FE 7C colon 4 times 0, right? And that must be your interface ID now here. If you look at the output of IPv6 interface brief, so this is what FE80 dual colon. Of course it will start from there, right? And then C000, yes, that is C000, right? And then 0DFF, 0DFF, 0 is understood, 0 is understood here, and then FE7C, yes, it is FE7C, and then finally 0, which means four zeros are understood, right? So in this way, it will be calculating its link local address. So once you enable IPv6 onto any interface, it will create its link local address. But remember that this link local address will never get installed in its local routing table. So to see IPv6 routing table, your command will be show IPv6 route, right? So you will never ever be able to see your link local address available in its, in the routing table of the routers, right? You will never find link local addresses.
So वो bit को change करने का क्या?
I don't know.
होता है.
होता है वो हमेशा होगा. And what I think about it, that in MAC address we have G and L bit. This is the GL bit, actually global and local MAC address bit, right? So I think so that this is one of the reasons so that we are converting it, right? Like in MAC addresses by default G bit is on, but when we create this link local address, we need to make it local. So that's why we are changing it, but I'm not 100% sure about it, right? Triple FE, because MAC address is just 48 bits long address, right? Whereas this interface ID is 64 bits long.
Okay.
So just to fulfill that requirement of having 64 bits for the interface ID, we are having those another 16 bits. That is triple FE, and that is fixed. That is fixed. You will never change it. Right? So in this way, link local address will be calculated by interfaces, right? Now, you could ask me that in case if we are enabling IPv6 on serial interface, then how will it be possible for serial interface to calculate its link local address? However, serial interfaces do not have, they do not have, MAC addresses, right? Serial interfaces do not contain MAC addresses. Then how would it be possible? How is it gonna to be possible for serial interfaces to create link local address? So remember that in case if your serial interfaces are there, then they will be using MAC address of first physical Ethernet port, whether it is fast Ethernet 0x0 or it is Ethernet 0 or it is gig 0x0. It will always be using the MAC address of first available Ethernet port. What does it mean? That now multiple interfaces can have same link local addresses? It's not it. If multiple interfaces are using same MAC address to calculate their link local addresses, which means that they are having same link local address, right? So of course, yes, it is possible in IPv6 that on a single device multiple interfaces can have same link local address, and there will not be any problem. You know why? Because link local addresses are locally significant within the broadcast domain, and one interface belongs to one broadcast domain. If you are having multiple interfaces, which means that you are having multiple broadcast domains. Are you getting my point? On a single router, if you are having multiple interfaces, which means that you are having multiple broadcast domains. And as I told you before, that link local addresses will be used in IPv6 within a single broadcast domain, right? Understood? So link local addresses are locally significant for a single broadcast domain, right? That is why it is possible that a single device can have multiple, can have same link local address on its multiple interfaces. That will not create any problem. You know why? Because data will never be forwarded with using link local address, actual data. And the link local addresses are not routable.
If I remember correctly, you said there is no broadcast in IPv6.
Yes, there is nothing like broadcast.
Then how can broadcast?
No, there will not be any broadcast. You will never ever require to perform broadcasting.
Right.
There is no ARP request. The only thing was to have broadcasting was, like ARP request and all, right? But here, they do not have any ARP request and all. Right? So this is the way actually to understand it. Now for an example, let's say that on its R1's F0x0, I'm gonna to allocate IP address FC00:182.168.101:/64. Any problem? I'll be allocating an IP address in this range, right? So I'll be allocating 101:1 on R1's F0x0. So let me do that. F0x0, no IPv6 enable, say IPv6 address directly, right? And that is FC00:192.168.101://64. 101.1 you know 6/64, right? IPv6 address actually, right? And then say no shutdown. So this time you see that you have allocated this unique local address, right? This is called unique local address, kind of private network, right? Because it is starting from FC00. And now you do not get confused that okay, we are using here 192C. It is also, you know, part of hexadecimal, right? So do not get confused. I just used 192.168 just to simplify it, right? Otherwise we could use like FC00, ACD0, right? FEF0, whatever it is, right? But just to simplify it, I'm just using 192.168.101, right? Dual colon 1, and I took /64, which means that first 64 bits will be for network and remaining 64 bits will be for host. It is same as IPv4. The only difference is that in IPv4 subnet mask was defined in decimal format as well, right? But here you will be allocating your subnet mask in prefix length, in the format of prefix length, right? Like /64, /70, or /80, /120, or /128, whatever it is, it will be depending on you, right?
So this double column has 3 blocks of
Yes,
zero.
and of course, and all of them are having zeros.
Zero.
Yes.
That's what we are doing.
Yes, right? And now you see show IPv6 show IPv6 route. This is the routing table now. For one interface, there will be always 2 entries. One will be on /128. That is happening in IPv4 as well in latest iOS versions now. Like if you are working on iOS 15, then even IPv4, if you have allocated IPv4 addresses to your interfaces, then it will create 2 entries over there, one on /32 and one on exact prefix length, right? Similarly here in IPv6, even it was happening in older iOS itself, right? So here you can see that we are having 2 entries for a single interface. One is on /128, and this /128 is for that IP address specifically that is allocated by you on this interface, right? And another entry is for you know, network ID. So remember, in routing table it will be advertising only this entry. I mean, whenever it will be giving an update to its neighbors, whether you are running RIP, LCRP, OSP, or whatever it is, right? It will be advertising only this thing, right?
Do we use this kind of format in real life for 192.168?
Yes, in IPv6
In
address, of course we
Make it
use,
simple.
of course, to make it simple. As that's required actually, otherwise it won't be possible to memorize IP addresses, right? Fine. So in this way you can allocate an IPv6 address, and I told you that once you will allocate an IP address, your router will start sending, you know what, router advertisement periodically. You have to wait for next scheduled router advertisement, right?
So sub interface की placement क्या होगा?
We have defined it already. /64.
/64, right?
Yes,
Right.
this is the subnet,
Right.
which means that in IPv6 again, subnetting, supernetting, everything is possible, right?
Right.
We will be doing that.
Right.
We do that actually. Summarization and everything is possible in IPv6 as well. So this is the way actually, right, to do it. And you see that now it is sending router advertisement. You see, this is router advertisement, and this is the Ethernet header, right? And then this is IPv6 header, in which it is having source IPv6 and destination IPv6, right? And you see that source IPv6 is its own link local address. R1's link local address, right? This is link local address inside the IPv6 header, right? And destination IP address is what? FF02:1, which means that for all, this is multicast address, right? FF02:1, which means for all. It is starting from FF, which means it is a multicast address, right? And if you convert 224.0.0.1 into, you know, IPv6, then it would become like FF02:1, right? So this is a multicast address, and then it is using ICMPv6. As I told you that finally it will be using ICMPv6, and this is type what? 134. In book it is also mentioned that it is type 134, right? Type 134 message. Then it is having like hop limit, and then it is also having so many things, so many other things, like it is having MAC address of itself, right? And then it is also having its MTU size. Then it is also having prefix information that we allocated on this interface, unique local, right? And it was on /64. That is why it is having its, you know, first 64 bits. You can look at this. So as I told you that router advertisement would be containing prefix information, would be containing MTU information, would be containing MAC address. So this information is propagated within the router advertisement message, right? So this time this router is generating router advertisement periodically, right? This R1 is generating router advertisement out of this interface, right? This F0 by 0. So you know, right now R2 and R3, they are not enabled actually, right? We haven't no shut. I mean, we still on R2 and R3 their interfaces are administratively shut down. So we have to no shut them, right? And then only they will start behaving. So let's move on R2, and the very first thing that you have to perform on R2, let's say that we want to enable IPv6 unicast routing onto R2, and then let's move on our F0 by 0, say no shutdown, and then say IPv6 address autoconfig. I'm not gonna to allocate an IPv6 address to this you know, to this device this time, right? And we will see that it will be getting IPv6 address automatically. That's what the meaning by IPv6 address autoconfig. And here we have not configured any DSCP yet, right? Did we configure any DSCP in this network? So what I told you before, that NDP, neighbor discovery protocol, can perform tasks same as like DSCP. It will be performing task as ARP, gracious ARP, you understand? And apart from that, it was also performing path MTU discovery, and so all these tasks were performed by NDP, right? So this time it is going to perform all that type of thing. It will perform all those things now, and you see that, what is this? You understand? So this is the router advertisement. Let me show you that the very first thing that neighbor solicitation were generated. Let me make you understand it, right? So this is the neighbor advertisement, neighbor solicitation actually. This is the neighbor solicitation, right? And this neighbor solicitation is generated by R2. How can we say that, okay, it is generated by R2? See, source address is unspecified. And remember that if any device doesn't have any source address, I mean, if you captured one packet, right? And IPv6 header was there, and inside the IPv6 header, source address is not specified, it's unspecified. Unspecified, which means that it will be dual colon, right? Which means that it was not having any address. And this time this neighbor solicitation is generated by R2, and if you wanna verify it, you can look at this, that this is what neighbor solicitation. And this time its target address is this, right? And you know why we were having this target address in gracious ARP? Do you remember the uses of gracious ARP in IPv4? Gracious ARP was used by IPv4 to detect duplicate IP addresses, right? So this time when I said IPv6 address autoconfig, first of all, this device generated its link local address, right? It's on link local address, and it will generate that link local address automatically, dynamically, but it has to confirm whether it is having a unique link local address or not. Are you getting my point? R2 has to confirm that whether it is having a unique link local address or not, or is there anybody else which is using same link local address, right? So it has to verify that whether it is having unique one or not. So for that purpose, R2 generated this neighbor solicitation, and in that neighbor solicitation, target address is its own link local address. Like in gracious ARP, target IP was its own IP address, right? Hello. In gracious ARP during IPv4, in gracious ARP, target IP address inside the ARP message, right, was its own IP address. Similarly over here, target IP is its own link local address. So now if anybody else is having same link local address in this subnetwork, right, then it will respond back. It will generate neighbor advertisement, right? And if it does not get neighbor advertisement back in the response of neighbor solicitation, which means it is having a unique link local address, right? So this time we saw that okay, it was generated, right? But there is no neighbor advertisement in the response of neighbor solicitation, and after some time again neighbor advertisement was generated, right? Neighbor advertisement after some time. But who generated this neighbor advertisement? This neighbor advertisement is again generated by R2. This neighbor advertisement is again generated by R2, and in this neighbor advertisement it will advertise its own MAC address. As I told you before, that neighbor advertisement would be generated in two different cases. First, in the response of neighbor solicitation. Second was like in case if its MAC address gets changed, then also it will generate neighbor advertisement automatically. So this time this device has came up recently, right? This device came up recently, right? And because this interface came up recently, so it has to inform others that okay, this is the MAC address, right? So that is why now R2 has also generated neighbor advertisement. See, this neighbor advertisement is not the response of neighbor solicitation, right? Because neighbor solicitation was generated by R2, so neighbor advertisement should have been generated by R1, right? But this time neighbor advertisement is generated by R2 itself, right? How can you verify that okay, whether it is generated by R1 or R2, right? So you look at the source IPv6 address and destination IPv6 address. Let me show you. If source IPv6 address is FE80C001, which means this is R2. And if it is C000, do you remember that it was C000 on R1, right? So C000 is on R1, but this C001 is C over here, right? This here you can look at this. Let me show you. Okay, let's move on. So IPv6 interface brief on R2. You see that this is what C001. Whereas if you look at R1, it's not it. So even this neighbor advertisement is generated by R2, and in this neighbor advertisement it is having, what is it having? Its own MAC address. This is the MAC address of R2 that it is giving in a neighbor advertisement. Fine. Then after, router advertisement is also there, and again this router advertisement is generated by R2. But in this neighbor, in this router advertisement, it does not have prefix information. It has only MAC address and MTU size, because there was no prefix configured on that interface, on R2, because we said auto config, right? So we didn't configure anything manually on R2. That is why it is not containing any prefix information over here, right? And router advertisement is generated by R2 because of R2 is also a router, right? And all routers in IPv6 will be responsible to generate router advertisement, right? And then after, you can look at this next message is router solicitation, and this router solicitation is generated by again R2. Router solicitation is again generated by, you see, C001, right? Router solicitation, right? Just to get prefix information, because it didn't get any prefix information yet, right? So to get prefix information from the neighbor device, you can see that its source now it has generated router solicitation, right? And this router solicitation will be delivered now on R1, and now R1 will be responsible to generate router advertisement immediately in the response of router solicitation. So this router advertisement this time is generated by C000, which means R1. And in this router advertisement, it is having like its MAC address, its MTU size, its prefix information, right? And lifetime. Got it? So this prefix information will be given to R2 now, right? R2. Now R2 has got prefix information from R1. First 64 bits. Remaining 64 bits will be generated by R2 by itself. Like you can look at R2 now, and you can see that first 64 bits came from in unique local addresses as well, right? But last 64 bits are copied from its link local address. Remember that if you are using auto configuration in IPv6, right? So of course in unique local address, last 64 bits will be generated by device automatically, and those 64 bits will be copied from its link local address automatically. So you can see the last 64 bits in link local address as well as in unique local addresses are same. Last 64 bits. But in unique local addresses, first 64 bits came from R1 itself, right? I hope that you people have understood it till now, right? So of course, I mean, these first 64 bits were taken from, R1, and then after it, you see, it has to confirm whether it is having this IPv6 address as unique IPv6 address or not. It's not it. It will calculate this IPv6 address automatically, but it, along with that, I mean, before allocating itself this IPv6 address, it has to ensure that whether it is the unique IPv6 address or not. So now again, it has to generate neighbor solicitation. It has to generate neighbor solicitation just to verify whether it is having a unique IPv6 unique local address or not, right? So for that purpose, you see that neighbor solicitation, and this neighbor solicitation is generated by, you see, again, a source is unspecified. You know why? Because still it is confused whether it will be able to use this IPv6 address or not, right? So you see FC00-191.68.101.C001, this is the target address, right? Because it wants to verify whether this IPv6 address is the unique IPv6 address or not. You understand? And then finally, neighbor advertisement. In neighbor advertisement, it will tell that, okay, I'm using this and there is no problem to use it, right? You see that this is my MAC address and this is my like target address, right? This is the neighbor advertisement, right? So there was no detection of duplicate IPv6 address, right? So this is the way actually that happens in the background of IPv6, right? So in case if source address is unspecified, which means that it is just verifying, it is generating gracious arc, right? It wants to verify whether it can use this IPv6 address or not, right? That is why source address is unspecified, and destination will be like in most of the messages, destination IPv6 address is a multicast IPv6 address, right? In most of the cases. I hope that you people have understood it.
First it did all that process for link local and then for unique local.
There are some other things also available. This is R1.
So what is the best practice? Keep it on auto config or manual?
Yes, it's good. If you are not really required to remember, if you are not really required to memorize that IPv6 address, then it will be better to use autoconfig. One more thing that I would like to tell you. See, I'm on R1, right? And I say no IPv6 unicast routing, right? I have disabled this IPv6 unicast routing. Everything is remain there. Everything else is remain, right? Now on R2, no IPv6 address auto config. Do show IPv6 interface. Does it have any IPv6 address now? Say IPv6 address auto config. Do show IPv6 interface brief. You will never get it. You will never be allocated IPv6 address. This is the T-shoot tactics actually. This is the T-shoot. So if you are not getting an IPv6 address automatically from your neighbor, it might be that IPv6 address is not configured on R1. Let's check it out. So let's move on R1, show IPv6 interface brief. And it can get this IPv6 address dynamically from the device only where you allocated this IPv6 address manually, statically, right? If on R1 also you are using autoconfig, then it won't be able, R2 won't be able to get an IPv6 address from there. Yeah, that's the problem. So at least on one device you have to allocate an IPv6 address manually. So this is, see, everything is fine, right? But still R2 is not getting an IPv6 address from R1. You see, it's not getting, just because of on R1 I disabled IPv6 unicast routing. So this is the uses of this command, right? Now once you have configured it, you see that it will get an IPv6 address automatically, right? But if you disable IPv6 unicast routing on R2, then it will not create any effect, right? Like you say no IPv6 unicast routing, right? So router what, sorry, now once again move on F0 by 0, say no IPv6 address autoconfig, do show IPv6 interface brief. Does it have anything? No. Say again IPv6 address autoconfig, do show IPv6 interface brief. You must get it. So if you disable this, right? So I hope that you people will be able to perform troubleshooting, right? Now one more thing that I would like to tell you, IPv6 unicast, I'm enabling it, right? I'm enabling this IPv6 unicast routing on R2 as well. And then they can also do one more thing on R1, on interface F0 by 0 IPv6 ND RA router advertisement, right? Suppress. They can also do that, right? So what is the meaning by RA suppress, router advertisement suppress, which means that it is not gonna to forward now router advertisement out from this interface. And in case if R1 doesn't send router advertisement out from this interface, then how will it be possible for R2 to get information of R1, to get prefix information of R1, right? So now if you move on R2, interface F0 by 0, say IPv6 address auto config, just disable it, do show IPv6 interface brief, you check it out, and then say IPv6 address auto config, so IPv6 interface brief. Never ever. Move again back on R1 and say no. Once you will say no, here you will be getting an IPv6 address. What ulta?
इस पे ऑटो कंपनी लगाया R1 पे, R2 पे मैंने ग्लोबल दे दिया, दे दिया उसको ऑटो, कौन सा उठाएगा फिर इसमें से? क्योंकि ये दोनों तो C000 हो जाएंगे ना उस केस में।
नहीं, दोनों नहीं होंगे C000। R3 पे जाओगे तो डिफरेंट मैक एड्रेस उठाएगा ये।
आपने बताया ना 7 बिट को तो चेंज कर ही देगा।
हाँ, तो 7th बिट को चेंज करेगा, उसके बाद चेंजेस होते हैं वो।
उसके बाद
हाँ,
जिसके पास पहले बात चलेगी उसका ले लेगा वो, या क्या?
अभी दिखाता हूँ, देखो अभी दो है ना यहाँ पे ऑलरेडी R1 and R2 are existing over here, right? If you move on F0 by 0, say no shutdown, and then IPv6 address auto, so IPv6 interface.
R1 से नहीं है?
Of course it will get it from R1.
पर अगर दोनों पे दिया होता
मैनुअली,
दिमाग में आ गया क्वेश्चन कि R1 और R2 पे दोनों पे मैंने
मैनुअली दिया है। हाँ, तो ये फिर
R3 किससे लेगा?
फिर यार जो भी इसको पहले ऑफर कर देगा उससे लेगा, जो इसको पहले ऑफर करेगा then it will pick an IPv6 address from there. Like they are saying that, let's say that on R1 and on R2 we have allocated IPv6 address, right, manually. Yes, manually, right? And then on R3 we said autoconfig, so from which one it will get an IPv6 address, right? So whoever will offer IPv6 address first, from there R3 will pick IPv6 address. That's it, right? So this is the way actually to do it. And one more thing that I would like to tell you, on R3, as you know that it has got this IPv6 address, right? So IPv6 interface brief. One more thing I would like to tell you, that IPv6 address autoconfig, just say no, right? And once again you will see that to show IPv6 interface brief, that it does not have any IPv6 address over here, right? And I can say IPv6 address autoconfig and default. So IPv6 interface brief. Of course, it must get an IPv6 address, but along with that, you see it has got IPv6 address. But along with that, now it must have a default interface F0 by 0 shut and no shut. Just wait. It must have a default static route, right? to IPv6 route. Check it out. My God. Should run interface. See, I haven't done anything, right? But R3 was not taking this, was not having this static default route. It will show you like it is statically configured, right? But actually it has got this default route automatically. And it is, it is configured or it is installed in its routing table towards R1. C00. Right? So in this way it can have this this default route as well. And one more thing, that for an example, let me prove it. Sorry, interface FA0 by 0. Sorry, now IPv6 address autoconfig. Do show IPv6 interface. No, nothing. Now I said IP address autoconfig. Show show IPv6 interface brief. It must get an IPv6 address. Show IPv6 route. Does it have any static default route? Now, according to your question, they said in T-shoot that R2 must have a default route, right? So you decided to move on F0 by 0 and you said IPv6 address autoconfig and what? Default. What is it saying? Fine. Then you will be looking at, but it will never appear. So remember that if you are going to configure this command, before configuring this command you need to remove existing one. Say no IPv6 address autoconfig, and once again say IPv6 address autoconfig. Now it will work fine. So IPv6 interface brief. So IPv6 route. Otherwise it will keep on to show you that okay, it is already configured, but it will never show you this default route, right? Default route will never get installed in its local routing table. Fine. So this is the, these are the problems that you can face during troubleshooting, and I have told you now that okay, how will you be able, or how can you rectify them, right? How can you fix them? These are the very small things, right? But really tricky. Fine. So I hope that now you people have understood that how can we configure this IPv6 addressing. Apart from it, you can also do one more thing, like if you want to know that how can we modify link local address, right? Link local address. So I'm going to modify link local address on R2 now. Interface F0 by 0. You can say that IPv6 address and it is FE8, right? In place of FE8 you can also take FE9. You can also take FEA, right? Even you can also take FEB, right? Dual colon 2, and this is what it will accept it. But if you say FEC, it will not accept it. If you say FE7, it will not accept it. If you say FE8, it will accept it. Do show IPv6 interface brief. Check it out. Now it is what? FE80 dual colon 2. And I told you that if you are using autoconfig, last 64 bits will be copied from your link local address. See, I just modified link local address on R2 and it has modified its unique local address accordingly, right? Because it is it gives us guarantee that in case if link local address is unique, which means that of course last 64 bits in case of auto configuration will also remain unique, right?
Same broadcast.
Yeah, in a single broadcast domain, of course, in a single broadcast domain. Then you can move on R3, and on R3 you can say interface F0 by 0 IPv6 address, and this is like FE 80 dual colon 2 and what? Sorry, see, duplicate, right? So here I'll make it. Now you see, show IPv6 interface brief. Yes, you see. Last 64 bits have been copied from link local address. So this is the way to change your link local addresses now. One more thing that I would like to tell you over here, like from R1, if you say ping FE80 dual colon, that is 2, right, on R2. If you ping link local address, it will always ask you output interface. You know why? Because on a single device, multiple interfaces can have same link local address. That is why it will always ask you output interface. But if you are pinging either unique local address or global unicast address, it will never ask for output interface. So this time we have to tell that, okay, fast Ethernet, and you see, show IPv6 name. This is ARP cache, or you can say this is IPv6 cache. So these are their link local addresses. You see. Right? If you wanna ping, like ping FE80 colon 192.168 colon 101 dual colon 2. Okay, ping FC actually, right? Yeah. Right? And then you can also ping with dual colon 3. Show IPv6 neighbor. Check it out. It has learned neighbors' MAC addresses with the help of those MAC addresses only. Neighbor advertisement, neighbor solicitation, and everything, right? In neighbor table, it is also having some states over there, like delay, stale, reach, everything. Reach is like it verified connectivity in past 30 seconds. If state is reach over here, which means that it verified reachability with using this MAC address with this IP in past 30 seconds. Stale, it has not verified this MAC address for this IPv6 address in past 30 seconds. And once your state has moved into stale state, after 30 seconds, of course, let's say that you have stopped sending data, right, for a MAC address. After 30 seconds, its state will move into stale state. And then after, if you start to send traffic again, right, then it will re-verify, I mean, it will recertify that whether this is the this is the MAC address. Is this MAC address is the correct MAC address, right? So for that, it will again generate like neighbor solicitation and everything, right? So that's the point. So there are some states as well in IPv6, like reach, stale, delay. I think probe is also one of them, right? Probe. I don't remember all of them actually. I think 4 or 5 states are there. You can go through them by yourself. This is ARP cache. In IPv6, you will be calling it as a IPv6 cache. Understood? Apart from that, you can also do one more thing, like I'm on R1's S1 by 0. I'm on serial interface now. Let's allocate IPv6 address like 2000. अभी तक भी नहीं है, आ तो गई, ऑन करा दो, फाइन. So 2000 colon 192.168 colon 1 dual colon /64 and then after I can say EUI 64. Try to understand now. It means that we are allocating for 64 bits by ourselves, but remaining 64 bits will be calculated by this device automatically with the help of interface ID. So in this manner, you can also allocate an IPv6 address to the interfaces onto routers, right? And then say no, shut down. Now you see show IPv6 interface brief. Check it out. It's not it, and it has copied interface ID of fast Ethernet 0 by 0 itself, because serial interfaces do not have their MAC addresses, so it will be using MAC address of first available Ethernet port, right? And that was fast Ethernet 0 by 0. Then we can move on R4. Interface serial 1 by 0 IPv6 address like 2000 colon 182 colon 168 colon 112 colon 2 slash IPv6 unicast routing. Similarly, now I'll modify this R1 as well. In place of EUI, I'll be allocating this IPv6 address by manually, right? So I'll be saying no, and then 112 colon 1 slash 64 itself, right? Do show IPv6 interface brief. Check it out. Show IPv6 route.
So why did we assign global unicast on this serial?
What?
This 2000 is global unicast.
Yes, globally aggregatable address.
What is the difference when we assign unique
Public,
global-
private.
Okay, public.
Sir, in this manner, can we configure IPv6 address in the directory?
Who's allocating these global IPv6 addresses? Like we have authorities who
I know, same.
I know same. Happening.
Yes.
Really happening.
So I hope you people have understood it now, right? Now let's say that from R4 we want to communicate with the lane of from R4 we want to communicate with the lane of R1. So you see show IPv6 route. Does it have any information about the R1's lane? For static routing, it's very simple, IPv6 route, and now we can specify FC00 colon 192 colon 168 colon 10112 colon slash 64, and then we can specify next hop address along with exit interface. Next hop address is going to be now 2000 colon 19168 colon 112 colon 1, right? That's it. This I mean it's same as IPv4. So IPv6 route, check it out. It must be there now. Yes, it is there. And now you can try to ping with FC00 colon 182 colon 168 colon 10112 colon 1. That was the R1's IPv6 address, right? You can communicate with without any problem. If you want to configure static default route, then it is very simple, IPv6 route dual colon slash 0, and then next hop address for exit interface, right? So this time you will be having a static default route as well. This is the way to configure static default route. If you are having fast Ethernet link, you should make sure that you are also specifying next hop address along with exit interface. So these all are the basics of IPv6. and then we can start any routing protocol now, like API, CRP, OSP, FM, whatever you want. However, everything will still remain the same. Right? So let's start it now. I'm gonna use (7200) series of routers. This is R1, R2, R3, and this is what? R4.
IPv4 and V6 are not interoperable. They are not, right? So we have to have some gateway.
Dual stacking. Only dual stacking is possible. Like along with V6, configure V4. It's not possible that source is V4 and destination is V6, because in a single IP header or IPv6 header you cannot have both
Right.
V4 and V6, right?
But on a single interface, we can have both IP addresses, like V4 and V6.
What?
On a single interface, we can have both IP addresses.
Yes,
V4
of
and
course,
V6.
of course, we can have that.
And router particular.
Fine. So here I'm going to use 2000 colon 192 colon 168 colon 12 dual colon slash 64. In between R2 and R3, I'll be using 23, 34. In the lane of R1, FC00 colon 192 168 101 dual colon slash 64. Interface of 0x0 IPv6 address 2000 colon 18168 12 12 colon 1 slash 64. Loopback 1 IPv6 address FC00 colon 18168 101 12 colon slash sorry, right? Show IPv6 interface. Done. So this is R1. Let's move on R2 now. F0x0 IPv6 address is going to be 2000 colon 192 colon 168 colon 12 dual colon 2 slash 64 0 by 1. That's going to be now 20. The loopback 1 IPv6 address FC00 colon 192.68 102 colon 1 slash 64. Any number.
8, 16,
Any number.
or
Same as V4.
multiplication of 8
Same
or
as V4.
anything.
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 Same as V4.
Up to 127.
128.
128.
Fine. Then on R1, so IPv6 route, right? And now you see, we are going to, I'm going to configure EIGRP named mode directly. I'm not gonna for classic mode. You know very well that how to configure EIGRP classic mode for IPv6, right? So I'll be configuring named mode only. It's quite simple, like router EIGRP. Now you see name, right? That's the name you took, and then you just need to define your address family, right? Like address family IPv6 autonomous system, and let's say you took 100. It won't take place unless you configure router ID, because you haven't configured any IPv4 address on this router, right? And router IDs will still be configured in the format of IPv4 addresses. So you have to allocate your router ID manually now. Router ID like EIGRP router ID, that is, let's say 1.1.1. That's fine. And you see, you are not required to configure any other single command. EIGRP will get enabled on all interfaces automatically now. You see, show IPv6 EIGRP interfaces. Check it out. EIGRP is enabled, right? Now I'm on R2. Just wait. Fine. So I just need to enable EIGRP now on R2, and it's quite simple, same as R1. Router EIGRP CCIE address family IPv6 autonomous system is what 100. Neighborship will not come up. You know why? Because router ID is not configured, right? Once we will configure router ID, you will see that neighborship will come up automatically. You are not required to specify any network command. Like in classic mode, it was required to enable EIGRP under interface mode, right? But here it is not necessary. Then move on R3. Similarly, router EIGRP CCIE address family IPv4 autonomous system. That this AS number must be same, right? Because all other rules are same. Metric calculation formula and everything, everything is same. Authentication, everything. Then say EIGRP router ID is what 3333, and then I'll move on R4. Router EIGRP CCIE address family IPv6 autonomous system is 100, right? And EIGRP router ID is what? What is happening? Okay, EICRP is not running over here, right? So IPv6. No, EICRP, UCIe, so IPv6 protocol, nothing. IPv6 router, sorry, router EICRP is what? CCIe, address only IPv6 autonomous system 100. EICRP router ID is what? Yes. I think on this device I configured EICRP in this manner, IPv6 router EICRP previously. Do show history, let me check it. No, I don't know what was happening. Fine, this time it has found neighborship with both of them, right? And now you can move back again on R1 and you can see show IPv6 EICRP neighbor. Yes, it is having them. So IPv6 route, it is having all of the prefixes like FC 102, 103, 104, all the prefixes are coming over here, right? So now the problem of EICRP named mode is that on all interfaces EICRP will get enabled, right? That's wrong, because there will be some interfaces that we would not like to advertise into EICRP, right? And by default EICRP is going to advertise now all the prefixes, right? All the interfaces. Fine. But how can we solve this problem now? Not passive interface, because if you configure an interface as passive interface, it will stop sending hello messages out from the interface, but still it will keep on to advertise that prefix into EICRP, right? So for that purpose here you are having one option like router EICRP, that is what was running over here? CCIe, and assembly it was IPv4 autonomous system, right? And it was 100. Let's say you do not want to configure EICRP on interface loopback, right? So you go to AF interface, right? Loopback.
IPv4.
And that's going to be IPv6 autonomous system 100, right? AF interface loopback, that is 1, and just say, which means that EICRP will be shut down now for this interface. This interface is not shut down. Actually EICRP is shut down for this interface, right? And now you will see that if you say show IPv6 EICRP interfaces, you will see that now EICRP is not enabled on that interface. And if it is not enabled, then of course you will not get it on R2. Yes, 1 is not there. There is only 1 or 2. See, it is starting from 1 or 2, right? But once you will say like router EICRP CCIe address family IPv6 autonomous system, no. And in T-shoot, what can they do? They can say AF interface default, and then EICRP will be shut down on all interfaces, and you will think that okay, EICRP is enabled, everything is perfect, but still EICRP is not enabled on any interface. So they can also do it, right? Say no, shut down. Is same. If you are taking 1/126, which means you are using only 2 bits, right? Which means 4 IPv6 addresses will be there. Right? Subnetting, supernetting, I mean, summarization is also same. Like for an example, if you are having prefixes in this manner, for an example. Right, this is right. 0 0 0 0. We know very well that up to here everything is same. Changes are occurring in last character only, 1 2 3 4. And if you convert 1 into binary, it will be 0 0 0 1. If you convert 2, 0 0 1 0, 3 0 0 1 1, 4 0 1 0. Even this bit is also same. Changes are occurring in last 3 bits only, right? So what can you say now? You can say FC00 colon 192 colon 168 colon 0100, because last will also become now 0. You will perform AND operation, right? So 0 dual colon slash, only 3 bits were different, right? So you will be taking 61. So it's same as IPv4. So everything is possible in IPv6. Subnetting, supernetting, summarization, whatever you want, right? Like here, so IPv6 route, it is receiving 102, 103, 104, all of them. Now I want to configure this R2 so that it will advertise only summary route towards R1. So what can we say? Router, not auto summary, router router ESERP CCIE. There is nothing like auto summarization in IPv6, right? Address family IPv6 autonomous system is 100, and then go to AF interface fast Ethernet 0/0, and then say summary address, and that is what FC00 colon 192 colon 168 colon 11100 dual colon slash 61, right? 61. So you will see that now R1 will be receiving only, there is no 102, there is no 103, 104, because all of them have suppressed in this summary address. So you know everything is same as IPv4 now. You can still communicate with ping FC00 colon 192 colon 168 colon 104 your colon 1. That's fine. So IPv6 ESERP topology. So IPv6 ESERP neighbors. So IPv6 route ESERP. Everything is same. Router ESERP CCIE address family IPv6 autonomous system 100. You will be configuring under other topology base or address, AF interface, right? Topology base, and then here you can configure all these things. There is nothing like offset list in IPv6 yet. There is no offset list in IPv6. Only these commands are available in topology base. And if you go to AF interface fast Ethernet 0/0, only these commands will be applicable. These commands in EICRT, right? Passive interface, split horizon, summary address, hello interval, hold interval. You will be doing it by yourself, authentication and everything, right? Authentication, and it can support now, you know, like mode, both of them, MD5 as well as SHA HMAC. Same as IPv4, right? So in place of taking IP address assembly IPv4, you are simply taking IP address assembly IPv6.
Route map.
Although in IPv4, yes, a route map is there, right? For, I mean, like to perform route filtering, there is no route map. To perform route filtering, there is no route map available in IPv6, right? Except BGP. In BGP, route map is there. But in ASGRP or SPF, you can't use route map to perform route filtering. But during redistribution, you can use route map. Like here, if you perform distribute, if you configure distribute list, so you have to say topology base, right? And then say distribute list. You will be getting only one option, that is prefix list. In IPv6, you can perform route filtering with the help of prefix list only. Right?
But in firewalls, we can configure ACLs based on IPv6 or not.
Yes, of course you can. Everything is possible. Like here, let me show you IPv6 ACL, like IPv6 access list, and then you can take like any name, like we took CCIE, right? And then we can say permit deny, whatever it is, right? Like let's say deny, right? ESGRP deny, and then we can say ESGRP, which means ESGRP is not directly there, right? So we can say its protocol number, that is 89, right? Or 88. Deny 88 any, right? And then permit IPv6 any. We want to filter ACRP based packets. Now go to F0/0. This is that how can we implement ACL, right, of IPv6 onto interface, and then say traffic IPv6 traffic filter, and then ACL name, that was in which direction. You will see now ACRP neighborship would be down here. To break up, I mean to break its ACRP peering now with its neighbor. You see show IP, you see down, because ACRP packets have been filtered by this ACL, right? Show IPv6 access list. So it is same as IPv4.
Commands are quite different.
Concept is same.
Concept is
अभी तक लग रहा था कि पता नहीं क्या है, थोड़ा right था। Good. इससे पहले था कि पता नहीं क्या हो गया था।
the main thing is migration strategies from
Exactly.
V4 to V6. How do we do that? If it's a new network, it's easy. But how do we migrate?
It's very simple. Let IPv4 in running state and configure IPv6, perform testing, and then
Shut down.
IPv4. It's very simple.
Easier said than done. It can run parallel. That's a good
Of
thing.
course, that's the best thing actually. That's called dual stack. You can also configure IPv4 parallelly with IPv6.
But in that case, how do we know which version is in use actually, V4 or V6? Because both are up.
It will be depending on end stations, whether they are accessing things with using IPv4 or IPv6, right?
So end station would have only one.
Of course.
IPv6.
Not only one. If you have configured IPv4 and IPv6 both, then of course. But I don't know now in perspective of system, right? In perspective of PC, I don't know that whether they will support by default. I mean, they will prefer IPv4 or IPv6 if they have both of them. I mean, if we have configured both IPv6, I mean both IP addresses, IPv4 as well as IPv6. I don't know. But router, if it receives any packet which is coming with the IPv6 header, it will process that. If it is coming with IPv4 header, then it will process accordingly. So for router, it will not be a big thing. So we have to do work on routers only.
From a migration perspective, we have to think end-to-end, like subnets में क्या IP addresses होंगे, PCs के endpoints के, and how the ACLs would work on a firewall.
Exactly. SPF version 3 over here, right? along with EIGRP. That's very simple. Like you say router OSPF. Here in this iOS, now you have both options, right? OSPF version 3 as well as normal OSPF. So if you want to implement OSPF version 3, say OSPF version 3, and in it, the best thing about it, like after, let's say after process ID, there is nothing like VRF. You know why? Because inside OSPF, inside router mode itself, you will be getting now address families. Like now you can say address family, and then you have both options, IPv4 as well as IPv6. Let's say you want to implement it for IPv6, then of course it's VRF is also there, right? But let's say that there is no VRF, right? Then we can say address family IPv6 only, right? Now you see that it couldn't pick router ID because we haven't allocated any IPv4 address to any of the interface of this router, right? So you have to say router ID, that is, let's say 1.1.1. right? And to enable OSPF version 3, see, in case of EIGRP named mode, EIGRP got enabled on all interfaces automatically. But in case of OSPF version 3, it's not gonna to enable OSPF version 3 on all interfaces dynamically. It will not, right? So you have to enable OSPF version 3 on all interfaces manually. You see, show IPv6 OSPF interface brief. You can see with using this command as well as show OSPF version 3 interfaces and brief. You can also use this command. Right? So now if you want to enable OSPF version 3 on interfaces, because for IPv6 there is no network command, right? So you do one thing, go to F0/0 and then say OSPF version 3 IPv6 and AS number and then area. Oh sorry, OSPF version 3 process ID was 10 and IPv6 and area, and let's say it is area 0. So OSPF version 3, then it's process ID, and then whether you're using IPv4 or IPv6, right? If you specify IPv4, which means that it will get enabled OSPF, it will enable OSPF for IPv4. And if you are specifying IPv6, which means that it will enable OSPF for IPv6.
In case the interface has both the address.
Exactly. So you will not require to run multiple processes of OSPF on a single device to configure, to run OSPF for IPv4 and IPv6 both stack. Because there are, we are having two different protocol stacks. One is IPv4 protocol stack and another one is IPv6 protocol stack. To configure both of them, to enable OSPF for both of them, you are not required to run multiple processes in OSPF version 3. Within a single process of OSPF version 3, you can run, you can enable it for IPv4 as well as for IPv6. Got it? That's the point, right? So now you see, go to loopback interface loopback 1, and in similar manner you will enable it. Now say show OSPF version 3 interfaces. Check it out. Right? And in case if you are having IPv4 addresses as well, like you allocated IP address 12.1.1 loopback 1. That's very simple. Go to interface F0/0, say OSPF version 3, 10 IPv4, area 0. Go to loopback. That's very simple. To see that, show OSPF version 3 interfaces will show you, show OSPF version 3 interfaces brief. It will show you both. You see, this is for IPv4 and this is for IPv6. It is there, AF address family, right? And to check its database, it is quite simple. Show OSPF version 3 database. It will show you that, okay, this is for IPv4 and this is for IPv6. This is for IPv4 and this is for IPv6. So it's really easy now to implement all these things. In similar fashion, you can move on R2 now, and you can say router OSPF version 3, 10, and then after this, this is router OSPF version 3.10, right? And then after this, we can say like address family, what IPv6, right? And then we can say router ID is going to be 2222, right? And then we can say interface F0/0 OSPF version 3, 10 IPv6 and area 0, right? In similar manner, you can move on to back 1. That's fine. And now it must form show OSPF version 3 enable. You see, it's DR 111 is DR, right? And fine. Show IPv6 route OSPF. Check it out. It has learned now R1's lane with the help of OSPF. You understand? And then after it is coming on /128. You know why? Because in OSPF loopbacks will always be advertised on /32 in case of IPv4, and in case of IPv6 they will be advertised on /128. Right? If you want to modify anything like priority and you want to configure authentication, it is quite simple in OSPF version 3, right? Go to F0/0, say OSPF version 3 authentication. Fine. Use anything. IPsec is kind of like either MD5 or SHA, right? If you say IPsec, then it's PI. You can take any number, like we took 500, and then you can see now MD5 or SHA. That's fine.
So like we have internet links from providers. We can ask them to allocate us IPv6 address also in the same interface.
Exactly.
Then some traffic on IPv6, some traffic on IPv4.
Yeah.
And slowly migrate it.
Exactly. Busy peasy still left. Even you know, in OSPF you need to learn so many things, so many new things actually, like router OSPF version 3, and this is 10, right? And then address from the IPv6, and then in it you see that you have all these things. I mean, everything else will be there in address family, and it is same as like you learned during OSPF version 2. The only difference is, I mean, the main difference is address family. Like now you can create address families in OSPF version 3. You want to change priority of any interface, go to interface, say OSPF version 3 and 10 and priority. You know, they have made it very simple. So if OSPF version 3 neighbor, you don't need to specify show IP OSPF neighbor, show IP OSPF database and all these things, right? Show OSPF version 3 database. That's fine. It's your turn. Just go through it once by yourself, and then we'll see you now